So we have two different things: sitting, eyes closed, or hopping. If you rolled an odd number on the top of your paper, it doesn't matter where it is, just somewhere so you're reminding yourself. So if you rolled an odd number, you're going to do S first, H second. So if you rolled an odd number, you're doing S first, H second. If you rolled an even number, you're going to do H first, S second. So we are going to time holding your breath. Which is similar to what we've done before, but we're just doing different treatments within. So if you are, whichever one I said is hopping first, stand up. So we're going to do both of these at the same time, regardless of which treatment you are. So we're only going to time twice instead of doing 4 of them. So if you are sitting, you're going to do sitting, eyes closed. If you're standing right now, you're doing hopping. Now, I'm not going to get into specifics about what is required for hopping or just kind of hop. So you're going to hold your breath as long as you can. We're all going to do it at the same time. As soon as you have to take a breath, write down your time for whichever one you're at right now, just somewhere on the top of your paper. Just do your sitting, eyes closed, holding your breath when everybody else does it. All right, ready, set, go. Anybody still holding the... All right, so now we're switching. So whichever one you weren't just doing, so if you were just sitting, now stand up. And I should probably take more time in between and whatnot, but it's not my concern right now. All right, so everybody's hold their breath, whether you're standing or sitting. 3, 2, 1, go. Still have anybody holding their breath? Okay. So we're going to use this we're actually going to start on the right side of the paper instead of the left side of the paper. So scenario 1, we are going to take our information which one I want to do first. You're going to number yourselves all the way through. So 1, just call them out. Chris, you're 2.
4, 5, 6,
7,
You might want to write down your number at the top somewhere so you know what it is.
9,
10, 11, 12,
15,
16,
17,
22, 24, 25,
28, 31.
So you guys have numbers now. So we've got 6 places right there. Let's call this one. I know I'm in the middle. Let's call this one. Actually, let's start here. S. So I'm going to randomly select 6 people, and I want to know your, which was sitting as closed. No, S was. So I'm going to do this to get the sitting as closed time for these specific people. How many did I have? What was the last number? 31. Carol, what were you? 31?
31.
8. 10. Who's number 10? What was your sitting as closed time?
30.
And y'all can write this in with me. Number 31. Caroline, what were you?
For sitting,
Sitting as closed.
35.
Number 1.
24.
26.
36.
20.
26.
And 7.
32.
Alright, so then we're going to move on to H. And now, because I'm using the same data so that I didn't have to neglect people or do things more than once, I might end up getting some of the same people by chance, but we can pretend that we're not if we want to. 31. So for hopping, what was your time?
26.
So this is hopping time. 23.
28.
Number 10.
34.
Number 8. Hopping time.
26.
26. Number 30. Number 30, hopping time.
32.
And number 29.
32.
Alright, so we randomly selected these. Let me go ahead and go straight to scenario 2 before I even talk about what we just did. Oh, I erased the wrong one. No, I didn't. Alright, so this is scenario 2. I still want the S and the H there. But this is going to be a little bit different. When I randomly select a person, I need both of their times. So, person number 2, what was your sitting eyes closed time?
20.
What was your hopping time?
23.
And I'm going to write 2 up there just because it doesn't really matter if I write it or not. Person number 4, what was your sitting eyes closed time?
28.
And your hopping time?
27.
Person number 22,
26. 22.
person number 31, what was your sitting eyes closed time?
35.
And
26.
person number 20,
26 and 24.
and person number 10.
34 and 30.
Alright, so the procedures we just did, were they the same? The scenario 1, scenario 2, are they the same? So let's write a little bit to go along with this. In scenario 1, let's just write randomly selected from S, then randomly, which is, I should have written out better wording, but this is fine for now. Then randomly selected from H. So in scenario 1, I randomly selected from my first group, and then I randomly selected from my second group. So in scenario 2, what did I do instead? What did I actually randomly select? So I randomly selected individuals, and then I did what? Recorded both for each. If I didn't write the 2, 4, 22, 31, 20, 10 there, would that have made a difference? So sometimes it's written there and sometimes it's not. With this one, I might write student number. So here, these 2 times are from the same person. So are they independent? If they're from the same person, are they independent? No, because like that person might have different whatever. So what would it make sense that I could do with those 2 times? I can subtract them. So this is scenario number 2. Would it make sense to find the difference for each column? Yes. So this would be -3, 1, 4, 9, 2, 4. Would it make the sense to find the difference here? So these 2 right here, did they have anything to do with each other?
No.
I like the way I wrote something. I thought I wrote. Yeah, I don't know what their name. Nothing in common, even though that looks terrible because they're both the number 32. The way I explain it, which is not like the mathematically correct reason for why it is, if there is a reason to do this, then it is a different kind of problem. So I look at scenario 1, and there's no reason for me to circle them because these 2 have nothing to do with each other. Whereas here, these are all the same person, then same person, then same person, so it makes sense to do that. Your information is going to look very similar the way it's given to you. Here is the one problem we've been doing the last 2 days. Here is different. I take these 2 numbers and then find the difference, and then at that point, I actually no longer care what these numbers even are anymore. So starting back here, when dealing with means and differences, there are actually 2 very different things that we can be measuring with means and differences. I don't remember what wording I put here. In both scenarios, the data appear to be from 2 samples. So the way it looks, it's going to look like 2 samples. And so the way I did scenario 1 and scenario 2 on this sheet is the same method I used scenario 1 and scenario 2 over here. I hope, yeah. So you don't need to know anything about those numbers or write anything there. So in the first scenario, there is no reason to the what about this, to the order. There's no reason at all to the order in which I wrote the raw data. I just went through it, the first person I came up with, second person, and went all the way through. There is no reason that the first value in group A is written above or below the first value in group B. These have nothing to do with each other. There's nothing in common. They are essentially independent of each other. So this method is yesterday and the day before. Here we would just be doing a 2-sample Z or T, almost always T, test or interval, or difference in means. In the second scenario, there is a reason to the order in which you write the raw data. The first value, I didn't write group here, but it doesn't matter. First value in A corresponds with the what as the first value in B. So the first value in A corresponds with what? The same individual. Here we actually aren't concerned at all with the raw data that we were given initially, only the what. What do I find from those? So let's go ahead and write the differences in here. Make it too much room. 1, -1, that's 3. -3, 1, 2. So once we find the differences for each, individual, so this looked like I have a 2-sample problem. But because these are grouped every single time, we actually treat it like it's only what? 1 sample. Well, have we dealt with 1-sample tests and intervals before? Yes, all of chapter 9 and 8. So this just means if it looks like this, we go back and use 1-sample procedures. Nothing's really doing any different. You just have to recognize that you go to that. Now, what we call it today, does anybody remember back in experiments? The experiment we just did, the way I did it, where every single person did both, and we randomized which one you did first and which we did second. Do you remember what kind of experiment that is called? Matched pairs. So this is technically a matched pairs that reduces to 1 sample. So this is a 1-sample matched pairs decision between T or Z, it's only Z if what?
Sigma Z.
What would we need to know the sigma of for this one, though? The differences. So would that make sense to have if it's So we're only given this data and this data. This is something we came up with. Would it make sense to know the population difference if the difference was something we were coming up with?
No.
So it's always going to be T because of that. We can still do a test or interval. It's still for means. Sometimes the way you get your information visually will look very different. Like here I wrote student number, and here I didn't. Some of them will actually even have a column made for or a row made for you that says differences, and sometimes it won't. So it's not the way that it looks necessarily is how you know that it's 2 sample or 1 sample match pair, but it's the context of what's actually going on that tells you if it is a 2 sample difference in means or a 1 sample match pair.